Welcome. We are under the aspect of what I call the radioactivity, and this is half-life calculation. Half-life calculations. Let's go. Under half-life calculation, please, you have to master these formulas at the board. The way you are saying it like this, you have to master it like this, critically. Looking at this four powerful formula, if you master these four powerful formulas at the board and you know what it stands here, believe me, there is no any question as far as half-life is concerned that you cannot solve. This is so powerful. From the board, you can see I said this is a formula. I said capital T is equals to small t all over log base of 2r. Is either you use this formula or you can use this thing that t times log 2 all over log r. Know very well. Your r is the disintegrating ratio. But this is the formula for r. When I start solving questions on this is so powerful. If I start solving questions on this, you will start seeing that this is so easy. It is so easy. Now, your r is 2 raised to the power of n, small n. I've already listed what it means here. I will explain it gradually. Remember, this is the part 1 of the video. This is introduction. And then you can see that your r is equals to 2 raised to the power of n. And then another formula for r is capital N1 all over N2. Please note this, that your small letter n is T all over capital T. Now come to this side. Now, we need to know what is the capital T. Capital T is half-life of radioactive element. Write it down. This is so powerful. The small t is the time taken for radioactive element to decay. It's different between half-life and the time taken. Note it down. N is the number of half-life. N is the number of half-life. N, capital N1 is the initial mass or initial number of atom present. Or you can also call it the initial count rate. When we start solving questions, you start understanding what I'm talking about. The capital N2 is the final mass or final number of atoms remaining. If this is the initial, this is the final. It can also be the final count rate. Write it down. While your R is a disintegrating ratio. Please, whenever I come to the part 2 of this video, at the part 2, I will not be saying all these things. I will assume immediately that you have watched the part 1. So I will go to the calculation immediately. You know, we don't like wasting time on this channel. The FR is the ratio of initial number of atoms remaining. Please note this. FR, the fraction of initial number of atoms remaining undecayed. That is the FR. The FD is the fraction of initial number of atoms that has decayed. This is, whenever you are seeing FR, just know it's fraction. This is the fraction remaining. This is the fraction decayed. Master these formulas, and if you can master it just the way I write it here, life is easy. Now, remember, under the formula of half-life, this is the 2 formula we can use. Remember that the number of atoms decayed, which is the ND, I can write the question I ask you to calculate the number of atoms decayed. Now, the problem is if you do not know the formula and you don't know what the formula represents, you cannot solve it. This is so powerful. So if you want to learn this topic, you have to write this thing down immediately. Now, so if at the part 2 and part 3, part 4 of the video, if I say calculate the number of atoms decayed, you already know that the number of atoms decayed is either N1 minus N2, or you can use N1 capital bracket R minus 1 all over R, or you can use this. Any of this formula can solve it. And if I'm asking you to calculate the fraction remaining undecayed, you will know that the fraction remaining undecayed is either you use N2 all over N1, or you use 1 over r. That means if you can calculate your disintegrating ratio, you can get the fraction remaining. If I ask you to calculate the fraction of atom decayed, it is now ND 1 over N1. If you know this formula, life is easy. It's either you are using this one or you are using any of this one, you will still get the same answer, depending on what they gave in the question. Write down this formula. Without this, you can't understand my next video. It's not possible. This is all you need for the introduction to half-life calculation. Thank you very much.